This is 1.4 quadratic equation. This should be a topic that you should be very, very familiar with. You have done this in other prior classes, so we're going to get straight into this. So a quadratic equation is ax squared plus bx plus c. There's your a, there's your b, there's your c, and you're going to use those quite often. The zero factor property, when you have two things multiplied together, if the result equals 0, you're going to set them both equal to 0. Oftentimes we factor it like that, and then we're going to set this guy and this guy equal to 0, and then solve for x. Now, there's different ways to solve a quadratic. You should, again, be familiar with all of these ways. You could solve a quadratic by factoring, the square root method, completing the square, the quadratic, and, of course, the calculator. Now, one thing that you need to know and say it a bunch of times, if you don't know it already, but whenever you solve an equation, the solutions are actually x-intercepts. It's where it crosses the x line. Even a simple equation like x plus 2 equals 3, when you solve for x, that's actually, when you graph this problem, that's where it crosses the x line at. It crosses at x equals 1. So even if you're solving, y equals x squared, or you find it x squared plus 3x minus 7, or whatever it is, you find it where it crosses the x line, or the x-intercepts. When you solve this, x equals 0, that's where it crosses the x line at. So make sure that you keep that in mind all the time. Every time you solve an equation, you're finding x-intercepts. All right, so let's first hit factoring. And again, I'm going to kind of go quick with this, just because we've gone through. You should be quite familiar with this. If you need to practice any of these methods, then obviously that's the method of weakness that you might have, and you need to work on that one area to make sure you're strong at it. So here, if we ask to solve this by factoring, we would notice that this is a perfect binomial. So x plus 5, x minus 5 equals 0. And that means then we're going to set this equal to 0 and set that equal to 0, and x equals 5 and negative 5. So here we're going to factor. 1 is out front. So this is where you're going to look for two numbers that multiply together to give you the last number, and adds together to give you the middle number. So x minus 4, x minus 3, set them both equal to 0. So x equals 4, x equals 3. And remember what those numbers mean? If I graph this problem, if I graphed it, those are x-intercepts. It's where it crosses the x line at. So here, if I factored this, if you use the AC method, that's fine, or slide and divide, or whatever method you use, or the guess and check, whatever the way, you're going to factor it, and you're going to end up with this. And then you're going to set this guy equal to 0, and so x equals 3/2. Set this guy equal to 0, and x equals negative 1. And remember, those are called x-intercepts. If I graphed it, that's where it crosses the x line. This one right here, this is minus 21, by the way. It's slightly off the screen. But notice I have 4 terms. So look at the first 2 terms, factor out your GCF. That would be 5x. Look at the second 2 terms. That's a 7 in common. Again, that's a 21 minus 21. Notice these are in common, so 2x minus 3, and then what remains is 5x plus 7. And then again, you set that equal to 0, and you're going to solve for 3/2. You're going to set this equal to 0, and you're going to get negative 7/5. And then this last factoring problem, we factor out the GCF. Then you're going to set this guy equal to 0, and set this guy equal to 0, and get your 2 solutions. Remember, I'm going to say it again, these are your x-intercepts. If you graph that function, like if you literally plug that into the graphing calculator and push graph, you'll see that it crosses at 0 and it crosses at 1/2. All right, the second type is the square root method. This is one of the faster methods how to solve. So if it's a kind of a binomial type problem, then you can easily solve it using the square root method. So here, we're going to take the square root of both sides, and don't forget the plus or minus. All right, so here we're going to add 9 first to both sides. Divide by 4. And then once you get down to here is when you square root both sides. So plus or minus, take the square root of the top, the square root of the bottom. And just say it again, these are your zeros, your x-intercepts. So if I graph that equation, like literally if I took 4x squared minus 9 and then like solve for 0, so 4x squared minus 25 equals 0, then literally change that for a y. So literally plug that into your calculator, and you will see that it crosses at 5/2 and negative 5/2. All right, so this one right here, if I minus 4 from both sides, divide by 2, and then to get rid of the square, I'm going to square root both sides. So square root both sides. So x minus 3 equals plus or minus the square root of 7/2, and then we're going to add 3 to both sides. Now, I will accept that answer, but just to let you know, I'll probably take a ½ point off if you leave it this way, because the square root of 7/2 is the same thing as the square root of 7 over the square root of 2, and you can't have a square root in the denominator. So you'd have to multiply by the square root of 2 over square root of 2, so you're going to get the square root of 14 over 2. Okay, so really this answer should be 3 plus or minus the square root of 14 over 2. And if I ask you to do a decimal answer, by the way, then you just plug this into your 3 plus the square root of 14 divided by 2, and then 3 minus the square root of 14 divided by 2. Those would be your decimal answers. All right, the third method is completing the square. So with completing the square, the a has to be 1. So in this case, it is. The second step is to take c to the other side. Then you're going to find a magical number. That's what I like to say, it's a magical number. Basically, it's b divided by 2 squared. So here, b is 2. 2 divided by 2 is 1. 1 squared is 1. So I'm going to actually add 1 to both sides of the equation. This factors perfectly. And by the way, if you, one of the cool things is, if you show this work right here, if you show that work, I know that's simple math, but if you show that work, see, 1 is what I added to both sides. The step before that is actually the factor. It's actually the factor. So keep that in mind because it will help you. All right, to solve this, we're going to take the square root of both sides. So x plus 1 equals plus or minus the square root of 7. And then finally, x equals negative 1 plus or minus the square root of 7. All right, to do this other one, again, the very first rule that for completing the square, the a has to be 1. So we're going to divide everything by 2. Then we're going to take c to the other side. Then we're going to do that magical number again. We're going to take b divided by 2 squared. So b is 4 divided by 2. 2 squared is 4. So I'm going to add 4 to both sides. So this factors now to x plus 2. See, 4 is what I added to both sides. The step before that tells me the perfect square there. So it's called completing the square. I'm going to add this together. I'm going to get 2.5 or 5/2. Take the square root of both sides. So x plus 2 equals the square root of 5/2, plus or minus. And I'm going to minus 2 from both sides. So negative 2 plus or minus the square root of 5/2. And again, getting this far is going to give you most of the credit, like most of it. But again, the square root of 5/2 is really this. And then you're going to multiply it by square root of 2 over square root of 2. And that's going to give us the square root of 10 over 2. So negative 2 plus or minus the square root of 10 over 2 is your final answer. All right, that's completing the square. But again, all of these answers are zeros or x-intercepts. If I plug that into your calculator, negative 1 plus the square root of 7, negative 1 minus the square root of 7, get me decimal answers. Those are decimal approximations, and that's where it crosses the x line at. All right, the quadratic formula. We're just going to do one problem with the quadratic. So to get quadratic, it's got to set equal to 0. So we're going to x squared plus 3x minus 9 equals 0. And you can see your a is 1, your b is 3, and your c is negative 9. So the formula says x equals negative b, so plus or minus big square root. B squared is always positive, minus 4 times the a times the c, divided by 2 times the a. So that's negative 3 plus or minus. Inside, if you simplify this inside is called the discriminant. If you simplify all of that, just plug it all in your calculator, but you'll get 45. Now again, getting that far is going to get you most of the credit. But notice the square root of 45 can be simplified. So negative 3 plus or minus 3 square root of 5 divided by 2. Now that is your final answer. Now let me rehearse something with you. If something can be divided, always look at these three numbers. If all three numbers can be simplified, then you want to simplify it. So if it said something like negative 4 plus or minus 8 square root of 5 divided by 4. Well, then think of it this way. Negative 4 divided by 4 and 8 square root of 5 divided by 4. The reason why it's a big long division bar is because both of them are being divided by 4. And then, of course, you would simplify that. Make sure you know how to simplify. Look at all three of these numbers here, all three of those numbers, and if they all three can be simplified, then you simplify. All right, the last thing I want to cover is the calculator. So I've been mentioning all along is making sure you know how to use the calculator. You can graph any of those problems and plug them in and find out approximate zeros. So let's look at any one of these problems on the calculator. So let's go back to this problem a couple pages back. I had 4x squared minus 25, and I talked about plugging this into the calculator and pushing graph. So here, if I go to the calculator and push graph, you'll see that it crosses at 2 point something. I don't know exactly where that is. I mean, I did find it. It is 5/2. But if you're doing this pure calculator, you'd plug it in as y equal, just like I did, push graph. And then there's a couple ways we can find this. But the easiest way to do this is if you go to second trace, you're trying to find the 0. So you press number 2. And then what you're going to do, it's going to ask you 3 questions. If you notice the calculator, it says left bound. So we're going to let's choose one of these zeros, and notice the cursor is there's a close. That's the closest it's going to let me get. So I'm going to go like really close to it, and I'm going to yeah. So this one right here is actually closer. So I'm going to go to the left of that. Left of that, I'm going to press enter. Right bound, I'm going to go to the right of that, press enter. And I'm going to press, go to the closest it will let me and press enter. And then notice it says negative 2.50. And that's what I got. So I got negative 2.5. And then the same thing, I could do the exact same thing to find the other 0. Just go to second trace, go to 0. Move your cursor all the way around until you get close to the other 0. And then do left bound, right bound, guess. If you get an error on your calculator, like a bound error, that means you didn't go left. Left means left of the 0, and then right means right of the 0. So you should not get an error, like a bound error, when you do that. And then lastly, and quickly, just to let you know, I'll give you random problems, and it takes a good skill. Like, which method would you use on each of these problems? Like, when you get to a problem, some people are finishing it in 10 seconds, others are taking 2 minutes. Well, it's probably because a certain student chose a different method. So when you look at number 1, what's the quickest method? It's probably the square root method, so x equals plus or minus 7. When you look at this one, that's a GCF problem. So you factor out the GCF. And so by picking the right method, this is a factoring problem. Then you factor this. By picking the right method, instead of like the quadratic or something like that. Factoring would be quicker on this if you're doing that. So picking the right method is a good skill to do, and that just takes practice.